All right, happy Monday and welcome to the memory team meeting. See, I'm still catching up from being off for a week, but let's just jump right into progress update by person or point pairs. Alexi, you're up with dynamic image resizing.
Yeah, we had a bunch of great discussions with Tim and Matthias on Friday, and Dmitry Grus also contributed to the discussion. And I still want to be on the same page about this issue, but as far as I understand, stakeholders are pretty much, I mean, Tim, pretty much want to go with dynamic resizing without considering static at all, because of we want to build one like universal tool for future content images as well. So that's how I feel. But Matthias raised a great concern. So why are we going with dynamic? Why we like ditched static so easily? And to be honest, I wasn't able to answer this question with the data I have. So I feel like we are going for dynamic just because it's universal solution. But I mean, to be honest, I don't feel like I have enough data to say like I would go for dynamic as well. Okay. So my idea is just to make some decisions. So we're going for dynamic. This is 100% because it's important to move forward and to not waste time on the discussions. And the next step is try to build some local prototype. I probably need to tinker with Workhorse a bit to inject these servers like image proxy. In our case, it will be behind the Workhorse, as far as I understand our infrastructure.
So I may have misunderstood. Did you mention that you also agree we should do dynamic, or you're saying that you're not quite sure why we would?
I pretty much worked with static only before, so I didn't have any prior experience to dynamic. But I feel like we want dynamic because we want to cover all of the issues in one solution. So I feel like this issue is not about like make some, some greedy short-term low-hanging fruits improvement to current situation, but to build the dynamic service because we need the dynamic service, especially for content. So that was my understanding of the issue. So that's why I feel like we should work on dynamic here, or either split the issue for like short-term improvements where static may be considered, or dynamic improvements for like, let's say, universal stuff.
Yeah, I'm still curious, and I think what we should do is my own 2 cents. But I mean, I think let's have a discussion here, obviously, that we should get some more data on what the value is in additional image types beyond avatars. It seems like 70% of, I think, the requests were avatars, and then the remaining question I think is, what percentage are commonly utilized other files, right? Like if you have a long tail of images that are used in issues and other things that are unlikely to be used heavily, will they even, what would our cache performance be like? Are we just burning CPU? What does it do to our cost? I'd be curious to learn more there before we just start moving on to dynamic.
Yeah, that's the right question. But do you know who I should ask about our like data statistics on our image data volumes? Because I could get like request rate, as Camille suggested this query from Kibana, but I don't know where to look, how to find, how much data do we have? How much data do we talking about? It's something like S3 statistics, right? Or whatever storage we use for our data. Should I ask him for lunch?
So Alexi, what kind of statistics you are looking for?
How many images do we have, and how much their total weight? I mean, in terms of how many gigabytes of images we are talking about if we need, for example, to resize every avatar. I could write a query probably.
I mean, there is something like uploads table that can give you some hint that this is avatar and can give you like the size, but it would be pretty extensive SQL query, but like this could be like fished with that method.
Okay, okay. I'm thinking maybe they have this stat somewhere already structured.
There is, I think there is like, I did not validate that, but I think that there is like very interesting characteristic with our image requests and the Cloudflare. Every request that goes to GitLab needs to be authenticated. It means that the Cloudflare likely multiplies the same avatar multiple of times, for example, because it cannot cache that avatar for many clients. It can only cache that avatar, like cache that file only to the single session that is currently logged. So technically, I'm kind of curious if we could, sorry, it's not really Cloudflare authenticates. Cloudflare needs to pass like authentication token for GitLab to authenticate each request, each individual different request. So I'm kind of wondering like how many unique requests, for example, for avatars we have in like maybe like in some window, because it could give us like indication if currently I believe there was like 120, 200 requests per second, but it's very likely, I don't want to validate that, it's very likely that we request the same file over and over because of the different user accessing that file. And we need to authenticate that this user, we need to authenticate this user to authorize this operation. So it can give us like some good information of how efficient would be caching. Is it like 0% or is it like 95% the caching would be if we would consider dynamic, but dynamic with the some cache.
That's an interesting take. Thanks. And I also wanted to ask you, like we should go for 200 requests, right? We shouldn't go for 304 type of responses because we only care about like newly served images which are not in browser cache. When we are talking about all these statistics, all this percentage.
Yes, like 200 is actual data being transferred.
Because yeah, I noticed
3xx usually I think is because if you have if non-match header on the HTTP where you can perform ETAC matching. But I don't really expect that like there is ETAC matching being really useful there. So I mean it could be interesting to see like the breakdown of 200 versus 304.
I noticed a lot of 304s in your initial query, like you provided for like Kibana. So I refined it, and it's totally different pressure if we only take 200. So okay, I will document it. Sorry for taking too long on this. So yeah, I think my next step is to make some clarity on points we like mentioned today as well, and to document them as well.
Thank you. Nicola, you're up. Oh, I'm sorry. Camille, did you get your questions answered?
It's kind of like open question, like because like we definitely gonna start with fully dynamic, but I think like for us to understand with the POC, if you would have to add caching for any reasons, like how it would fit into this architecture, who would be like creating the cache, who would be clearing the cache, because I mean in the end like there's gonna have to be some cache. It's super wasteful like to do it over and over, and like it's gonna eat like a ton of CPU and memory on a server when doing these resizes over and over. So I'm kind of like looking at two estimates, like one estimate and one like forward thinking, like estimate exactly how effective we assume the cache would be. So how big hit ratio we can get from the current data. Let's say, is it 0 or is it like 90? And second, like if we start with dynamic, what would be another building block to this architecture if you would have to implement the caching?
Yeah.
I mean, I agree. I don't think we should do like dynamic without a cache. Otherwise, we'll just burn through money. To your point.
It's like image resizing. It's like if you want to have a good quality image resizing, it's not cheap operation. You usually need to do some kind of bilinear filtering or like trilinear filtering, and it's not cheap. And doing one maybe gonna be fine, but there is also another aspect. It's gonna increase latency. This image resizing. It's not gonna be instantaneous. Maybe some images gonna be 5 milliseconds, but some of them could be 100 milliseconds. So we may be trading the egress traffic with the increased latency, and it may not be it may not give the benefit that we are looking for. So it's also like worth to see the size of the images and try to estimate how much latency the resizing gonna bring.
Yeah, to be clear, I'm not convinced we should do dynamic resizing. I'm not sure. Yeah.
I would like to one more point from me, and then probably would require some help for Josh. I want to understand what is the parent initiative of this task. Is this initiative like make GitLab faster? Then surely going for static is easier and so on. And if initiative is like make some dynamic capabilities like team describe, like you upload some huge file and you get it like compressed, it's completely another issue. So I would like to understand what is our like underlying motive behind this task. Is to speed up GitLab, then definitely maybe going caching only for avatars is the best solution here because it's fast. We could easily implement it in models because we have carrier wave, and it's cheap, and it's like super easy to do. And maybe we'll get some huge results really fast, and then we could go for dynamic for like a couple of months because it would take some time. So yeah, if we could refine this moment, it would be really fine.
So we use carrier wave, but we don't use carrier wave in the conventional way. So I would not say that this is gonna be easy to implement.
Why do you think so? I noticed that we don't have like resizing and carrier wave, but we have like let's say something similar. I noticed in or somewhere.
I think like one thing that I understood from that issue, the intent is to reduce the page load time. The data transfer of the avatar, so like any images, is significant amount of time, and we can reduce the load time by reducing the traffic. So this is the goal.
But we had latency, right? As I mentioned.
I mean, making GitLab faster from a user's perspective is the goal, which is, to Camille's point, reducing the page load time. That is 100% agree. I think the question, has become whether we do a sort of short-term solution, which might have high ROI, but might not be as extensible as a general purpose solution, or do we just fully invest in a much larger effort, or at least likely larger, for a general purpose dynamic solution? But I'm not sure we have the evidence to justify spending a significant chunk of time on dynamic resizing without looking in more detail at like what's actually being requested and how often. I have a feeling avatars are relatively common. They make up, I think, in the previous one, 70% of the overall requests. But random image uploads on random issues, that's probably a lot lower hit rate of a cache than anything else.
I like Alexi's comment earlier about breaking down the issue, because creating a dynamic image resizing universal solution is not an MVC, right? It's not an iterative approach. So maybe we break it down to attacking the biggest problem. It sounds like avatars is the biggest problem right now. How do we make that faster? How do we reduce the number of calls? So, but for now, let's take the conversation to the issue so we can move on to other items in this. So, no, fantastic conversation. But I think breaking this down to solving an incremental problem rather than trying to solve the entire problem of image resizing and making all of GitLab faster with its approach to images, it's probably not the best approach. So we'll take it to the issue. Nicola, you're up for improved performance of show JSON in the blob controller.
Yeah. Regarding blob controller, like we have a fix that is remembering number, like those nodes that we are iterating, and instead of parsing every time, we're now using that. But since blob controller, like the logic behind this reference filter is used in a lot of places, not just in the blob controller, like Henrik, you pointed out, like it's used in file preview, issue preview, the comments and everything else. And in case that something is wrong, like this fix can improve a lot of things. But again, if something is broken, we are, for example, remembering the comments and issues in the database so we can easily like load them faster. So in case that something is broken, we can maybe need to not just revert changes, but also clean the database, which is bad. So I introduced the feature flag behind this, and we needed to find solutions. So in case that feature flag is not enabled, that everything works as before. And even if some of those filters are used outside of the pipeline, that it still works, like that nothing is broken, because we don't have any benefit of remembering or caching those nodes and updating them if they're
I
not.
cannot hear Nicola. Could you?
Sorry? You don't hear me?
I could hear you just fine. I don't know if it was just Alexi.
So yeah, the issue is almost done. It's in review, but we needed to include the feature flag behind it. So it's gonna be more safe. So we can enable it for some of the projects for the beginning and then enable it for everything else. So we can roll out it more carefully this way. That's the bottom line behind it. Regarding GitLab metrics transactions, like a lot of people reviewed this issue, and what is left is that Camille take a final review, and then we can decide it, like what we are going to do with it. Like it's a lot of refactoring. It's a little bit risky refactor because it touches almost everything regarding our transactions. So I don't know, after Camille reviewed, we will discuss it and see what to do with it.
Okay. And then you have detect and reduce amount of cache SQL queries.
Yeah, I promised on our last Monday meeting that I will split this issue and that we can close this one and leave just the investigation part, because we fixed the data, so we have like, we can detect the number of cached SQL queries, but we need a separate issue for investigation, but I didn't still created those tasks. I will do it probably today.
Okay.
So I will just split this one and close the detect one and create a separate one for investigation. I already did some investigation on Thursday before my day off, and there are some interesting data on Kibana already.
Okay.
I shared those two data tables from Kibana on our memory channel. Maybe. But yeah, it's not important to be here. So, and that's it.
Okay. Grant, you're up.
Yeah, so I just want to call out, we found what looked like to be a memory bug with Sidekick when importing projects. It's kind of a surprising one to see. It's kind of a weird one. I just wanted to call it out and maybe a quick discussion about it because we do have the team set up an automated test for it, and that did correctly start failing as well. And that was raised and was investigated by the import team, I understand. But I think it was maybe missed that it was a memory issue because it's running against staging, and it's maybe not so easy to get stages metrics. Whereas on the performance test environments, I was looking at what was happening and looking at errors and stuff. It was clear it was maybe a somewhat of a memory killer, and that's exactly what it was. So I don't know. It's weird. We're doing everything right. We are testing it, in an automated fashion. The pipelines did start failing. It was kind of noted and investigated, but nonetheless, the cause was missed, and it got into 13.1. So I wanted to call that out and see if there's any points to be raised about it.
Grant, is it happening only on staging, or we were able to like reproduce it in local or on production, or I don't know?
It's happening against staging as the pipelines are failing. It's happening against the performance environments which running on the nightly. It was and it happened against the 13.1 Docker image. So yeah, it's a bona fide bug. It looks like across the board.
I'm wondering if this should go over to the import team.
If you want to reassign it, that's absolutely fine. Yeah.
So it's like it's the difference between 13.1 and 13.0, right?
It looks like on 13.0, importing this specific project, which is the GitLab FOSS project, which is not the largest project in the world, but it's a medium size, I'd say. In 13.0, from what I saw, it was only about 1.2 gig stable, which is what the Sidekick process took up, and then the 31 that climbs up to 2.9 at max. Then it drops a bit. I think that drop is natural as part of the import process, it seems. And then eventually it gets killed because Sidekick's memory killer is a little bit weird in that it doesn't actually kill itself until 50 minutes after it's detected. So yeah, so there's a large increase there of a gig plus.
Okay.
So
yeah.
if it's happening only on staging, we can try to disable this service measurement tool that is currently enabled only on staging. I'm just wondering.
Sorry to clarify, it's not just happening in staging. It is
It's
happening across
not.
every product.
Okay.
Yeah, this is happening.
Yeah.
Again, it is happening in staging. It's happening against the performance environments which run on the GitLab EE nightlies, and then we investigate further. It's happening against the 13.1 CE Docker image. So
yeah.
So it's a bona fide issue. The classic problem is that it's hard to get metrics out of an environment from the outside, which is what a lot of this thing is. The current test pipeline will just is uploading and importing an image, a project into staging, and then obviously with staging, it's not easy to then just go, can I get the memory please of that process? That's the hard bit, and that's why maybe this got missed. So I don't know if there's any. I don't know if there's any like boring solutions to this, but I just wanted to call it out because it was a miss. And I don't know if we might need to improve the pipeline in the future to actually call out memory usage. But again, that's difficult because you don't know which Sidekick node's actually going to do the import, and so on. So it's not easy.
Yeah, based on current workload, I'm inclined to send it over to project or to the group import team to take a look at it, see if they can figure out what's going on, and if they need some help, then
yeah,
happy to jump in.
No, that's fair enough. It was a hard one to place because it is import, but it's also memory Sidekick. So I don't know. We don't know what the cause actually is. It's probably safe to assume it is a project import issue more than a Sidekick memory issue. We're not seeing any other Sidekick memory weirdness, so that's a fair shout. So feel free to reach out.
Yep, I will. All right, and then I'll let y'all read telemetry updates. don't know if anybody has any feedback or working with folks on that. Jinyu and Matthias are not here. And then, all right, so on to unassigned work. So we had a couple items for rack timeout and Puma. One of those just got brought in this week. This one? No. So this is an older one where they were requesting to allow admins to configure rack timeout for Puma, and Camille mentioned that it's in the environment variables, but not well documented. And then there was another request here that Camille indicated we could bring in because it's low hanging fruit. Does anybody on this call have time to potentially pick this up in 13.2, noting that we have about 2 weeks left? Or does everyone feel pretty well loaded for 13.2? Because if so, we can move it out to 13.3.
Okay, so I can take this rack timeout should be moved out of Puma group. It seems fairly straightforward. And it's not related to the documentation that I have to write it on right now. So I'm just gonna take over that.
Okay, thank you. Then the other two assigned were telemetry and telemetry. So I would assume that either Chinyu or Matthias will pick those up. So anything else to cover for this week? The one thing I would bring up, Josh and I are working on the blog post for Puma. Josh, you had the one question on the MR about the end workers and end processes. Where'd it go? I believe this is true, but Camille, you can correct me if this is worded wrong.
It's correct. I just don't understand without all of the process overhead of managing end processes. Because like Unicorn kind of works the same. So I would just like remove the second line.
So remove that part.
Yes, and
Yep.
it's like it's exactly the same.
Yep. Okay. I will update that. Thank you. Oh, and then there was another question on there. Josh, I don't know if I can get this in time because the blog post is scheduled to go out tomorrow. And I'm not gonna be able to get to it by then unless anybody has that information available.
Isn't like 1.5 gigs or something like that. I could be. Do we know how much each worker costs memory wise?
Off the top of my head, I think it's between 700 megabytes and a gigabyte off the top of my head, but it depends on the context you're talking about at rest or on the load. Obviously, it will fluctuate a little bit, but I think up to a gigabyte is fairly it's a fairly realistic kind of way to describe it. Because I think that's the limit we put in the Puma memory, the memory killer as well. Sorry, I think it's a gigabyte.
Maybe we could link our Grafana page, which we have open, where we should have this data, right? Because we have memory consumption in graphs. Or do we need static number to put in there?
No, we can link, yeah.
Do we not
because
have?
I think,
sorry,
I think GitLab.com is fairly a good example, like a huge project under load, and which is using Puma. So maybe we could show them that we have this data.
It's 850 megabytes. Sorry for the memory killer. I was mistaken there. It was one. I think it was. I think I set it to 1 gigabyte at one point. So up to 850 megabytes. Do we not have data from customers now or something like that? I'm sure I remember seeing like there was a genuine reduction in memory compared before and after. Maybe it was one of our customers, but it's I can't grab it right now. But if that is that what you're looking for, kind of like a quantifiable example, or you just want to say on average this would be the memory use?
Yeah, I just wanted to show some quantified impact of the benefits here. I think we can grab, I think we have that language in the 13.0 blog post, actually, we can just reuse.
Yeah, okay. Yeah, that sounds good.
Yeah, so we say it saves for about 40%.
Yeah.
Josh, you want to just add a suggestion here, and then I'll make sure it gets in, and I'll get in the other update to the workers and threads on Puma versus Unicorn.
Sure.
Okay. All right. Anything else for this week?
I put up it higher in the agenda, but it's just a call. I'm feeling out a proposal to try and at least write down at least a process or codify. It's underneath my other item. Sorry, I put in indented by mistake. It's a kind of I'm trying to feel out a way to maybe start promoting and codify a way that teams can start doing performance testing kind of higher up the dev chain. It'll be easier for browser performance testing with site speed because you don't need a heavy server to do that. That's obviously specific to client performance, but server performance, that is more difficult, but I guess that shouldn't stop us. So I've run a proposal there, and everyone's more than welcome to feel free to read it and comment on it. The ultimate goal being that we have more dev teams adding in a performance test in some description or mobile test, depending on the component they're testing. I'm only talking about unit and smoke performance testing. I should qualify, but not talking about asking folks to do big, like quality will keep doing the big kind of integration tests. But the dev teams can do like smoke and unit tests to give them at least that more immediate feedback of, hey, this thing's actually dramatically slower. It shouldn't get released essentially, or shouldn't get committed until this is addressed. That's the idea, that kind of level of testing. So feel free to have a read and feel free to comment.
Thank you. All right, if there's nothing else, we'll call it. Happy Monday, everybody.